So yeah, I'll give a brief background about myself, who I am, and then I'm gonna get on with what we are building. So first of all, I have learned a lot in the past 3 days and met a lot of you, and it's been very exciting conversations, and uh, grateful to be part of this community and the Compute Over Data ecosystem. We started out about 3 years ago in the UK. Me and my co-founder, we initially were a fintech that was trying to create better tooling for debt capital markets, which is a very entrenched and archaic industry. We encountered many challenges while building products in that domain because a lot of the customers we were trying to sell to were these old financial institutions who cared a lot about privacy, about data ownership. And one of the reasons why we couldn't scale out and sell to these big institutions is because they couldn't trust us with their sensitive data. They needed guarantees that their data wouldn't be exploited, wouldn't go outside of our database to some other competitor. And we really didn't have an answer for that problem. So we started researching different approaches towards privacy. And in the past few years, there's been a lot of innovation in the space of privacy-enabled compute. And so we started building out tooling in that domain. And I think Filecoin on its own is an immensely powerful tool that can actually help enterprises get cheaper storage. But I think there's a need for privacy and privacy tooling in general to make it more palatable for enterprises. So this is what we're doing now. We've rebranded from our previous name to nCloud, and we build encryption and compute for sensitive data. So what is the problem that we're trying to solve? Cloud, obviously, today is very expensive. Even small to medium-sized organizations are spending millions. And this is a problem that Filecoin is solving. They have created this amazing incentive network where they've figured out a way to incentivize cheap storage. But cost still remains the largest priority for most organizations. They really want to optimize their workloads and save costs. And that's why Filecoin is such a compelling offering that most enterprises need to look at and consider seriously. However, one of the biggest missing elements within the Filecoin ecosystem is privacy. And unless this is solved, most enterprises and businesses, even smaller ones, will not, in my view, migrate to Filecoin. And there needs to be tooling in the community. There needs to be tooling in the ecosystem that enables this onboarding. There needs to be encryption, and Filecoin is moving towards a compute phase in its journey. But that compute cannot just be for public data. There has to be compute on private data as well. When this ecosystem gets that, I think there'll be actual disruption and challenge to the big cloud incumbents. So what are we trying to build? Where do we sit in? Filecoin already have a tremendous network of storage providers globally. They have, as I said, figured out a way to incentivize cheap storage. The FVM is on the horizon, which will make the whole ecosystem more flexible. You can embed smart contracts and create new active flows to incentivize different kinds of storage behavior. And I think with this, there's a confluence of opportunities because what we offer on top of that is confidential computing, encryption tooling, and something called data unions, where different enterprises can collaborate in sort of a trusted network. As I mentioned before, decentralized storage combined with privacy is a compelling offering for enterprises. We actually have talked to a number of storage providers in the past few months. We went through the ESPA program in Las Vegas. And one of the key learnings from there is that all these SPs have so much deal flow and inbound requests from real enterprises, but they all want some guarantee of privacy. And the SPs do not really have the right tooling in place. They don't have the right capabilities to onboard the sensitive data. And we want to solve that challenge for the SPs. What is our vision? Like, what in the ideal world would a decentralized cloud stack look like if it's geared towards enterprises and has privacy baked in? Starting at the bottom, you have obviously storage. Like, you need data to be stored cheaply and in a privacy guaranteed way. So what we've created is a storage CLI, which basically allows the user to generate encryption keys, perform key management, onboard the data onto Filecoin in an encrypted form, retrieve it, decrypt it back, and use it for their purposes. This storage CLI will open source a basic version of it, and then we'll have a different offering with certain advanced features as well. Graduating up from storage, the next thing is compute. Like, what do you do with the data that's stored across the Filecoin network? Obviously, you need to run compute on it. And the Bacalhau project is tackling that problem. They're creating a network where it's easy to run compute jobs. It's fully native and compatible with IPFS and Filecoin. And they have tremendous plans to scale out to thousands of nodes in the coming months and years. But I think one of the key elements that can really enhance Bacalhau is a implementation of it that is based on trusted execution environments. I'll come to this later in the presentation because it's worth having a discussion just on what TEs are. The third part of the stack, once you have performed the compute, is how do you collaborate? How do you actually leverage that compute and maybe even perform compute in a coordinated way with many different actors? And for that, I think Filecoin is truly an amazing product because it's an open ecosystem where if you have data, you can actually easily share and collaborate on that data with different participants. So why privacy, and who are the stakeholders that actually care about it? Storage providers obviously are the most important stakeholder in this entire ecosystem. But for them, hardware is a big investment. They spend hundreds of thousands to millions of dollars procuring very sophisticated hardware that they can use to perform mining, sealing, get their block rewards. So why would they invest in additional infrastructure just to offer privacy? The really profound answer is that they don't need to. And the reason is that most SPs today in the ecosystem use AMD-based hardware. Most of them run AMD EPYC processors, and these AMD EPYC processors actually have a certain part of the CPU that allows compute on encrypted data sets. This is not being leveraged today, and not many people are talking about this. And I think we've identified this opportunity, and we want to help these SPs to actually leverage their hardware and actually run this privacy-enabled compute. SPs also want to optimize cash flow. They can't simply rely on block rewards to sustain this business long term. And with Enterprise Fill Plus and Fill Plus on the horizon, there will be needs for privacy to be baked into the storage. And SPs will need to offer more capabilities just beyond basic storage. They will need an additional stream of revenue with the same hardware, which is going to be through compute. The second stakeholder who's very important, I guess even more important than SPs, are the clients, the people who actually use Filecoin day to day. And as I've mentioned before, if there is a drive and a desire to onboard enterprises and their sensitive data sets, there needs to be that compute and an encryption capability. We're seeing today that there's a lot of public institutions adopting Filecoin for archival storage. But even in this sector and in this specific subset of use cases, there is a need for sensitive data, sensitive archival data. And through what the solution that we're going to offer, these enterprises can actually access cutting-edge privacy technologies like fully homomorphic encryption and DEs at a accessible price point. Big Cloud today is actually gearing up, and they are offering confidential VMs as a core offering. and especially so in the past year or so. Satya Nadella from Microsoft is all over talking about confidential VMs on Azure. So I think there needs to be a Web3 offering that can challenge them in this space. Finally, for Filecoin, why should they care about privacy? Why should they care about onboarding sensitive data? Well, the answer is that the network has 20 exabytes of capacity, but there isn't enough usage. There isn't a optimization of what's there, of the hardware that's there. And to really get that capacity to be fully utilized, there needs to be offerings that enable that onboarding. And privacy and encrypted storage is, in my view, the means to achieve that and get to that better utilization. And as I've mentioned before, Enterprise Fill Plus is a new program that's being worked on by Protocol Labs, where they are incentivizing storage providers to onboard enterprise data and get even a higher multiplier on their block rewards. Okay, so I've suddenly jumped from something that was more commercial oriented to something that's a bit more technical. And I know the audience here is a mix of both technical and non-technical. So I'll entertain questions on this later on, but I wanted to share with you guys really and get feedback honestly, because this is a tool that's still experimental. We're we've completed the development of the open source version. In fact, we want to release the repo soon. But really, this is I'm vetting my ideas with you guys and just hoping for like a good discussion around these. So our CLI is going to offer a way to onboard sensitive data onto Filecoin. We understand from talking to different SPs and various participants in the ecosystem that the SPs need a seamless and smooth onboarding experience for data, and the clients want that too. Now, there is existing tooling today, so Estuary, that allows easy upload of data onto Filecoin. And what we've done is we've built a metadata management and encryption key generation facility on top of Estuary. So we allow, we leverage a technique called key wrapping, where a RSA encryption key, which is a key encryption key, is used to wrap an actual AES data encryption key. The AES data encryption key is actually used to encrypt the data. The encrypted data, the process of encryption itself can be optimized, because you could, for larger file sets, you could chunk the larger file sets and encrypt each of the chunks, and then upload them onto Filecoin. There also needs to be a very robust metadata management. So we've also created a metadata management service where it's a key value store. This key value store can either be maintained by the client in their own infrastructure, or ideally we want to get to a state where we integrate with decentralized storage, where they don't need to operate any infrastructure, and all this metadata is actually in a decentralized storage. Yeah, so retrieval is a challenge as well. And I think we've solved it quite well. So we use Estuary again to get the data back. We unwrap we query the metadata using the public key of the client. We get the encrypted DEK, decrypt that, and then decrypt the data, the individual file chunks, and recombine it into the actual file. As I mentioned before, we integrate with existing tooling, Estuary in this case. But we want to go beyond that and actually integrate with the Singularity and some of the other more lower-level deal preparation frameworks out there as well. Yeah, as I said before, like this, I'm really trying to get feedback and an honest discussion around our approaches and design choices, and actually what we plan to offer in the future. Today, I think the tool has, in terms of its encryption approach, key wrapping, which is a Web2 best practice in terms of encryption. So that's something we've implemented. The encryption metadata today is stored locally, but we want to get to that decentralized storage of that encryption metadata. And I think that will really lower the footprint for the client and allow them to really seamlessly onboard their data without spinning up any new infrastructure. and really trusting decentralized technologies. One of the key challenges is key custody and key management. And I've talked to a number of SPs and even people from protocol labs, and they all echo this requirement. No one wants to deal with key management. It's a pain, it's risky. And if you can create a solution where the client has something like non-custodial key infrastructure, where they can distribute the key, there's many approaches to this, but one of the most common ones that I'm seeing is through a startup called Web3 Auth that have created this way to implement Shamer's secret sharing, where you can partition the key into three parts. One of the parts is custodied by the client, but the other two parts, one of them is stored in their decentralized infrastructure, and it's fault tolerant, and the other part can be linked to something like an OAuth. You can have one of these parts completely eradicated and still recover the key and sign your data. So this is something we're looking at to integrate with our offering. I think this could really help, alleviate a lot of the concerns that enterprise clients have around key custody. We've already built out chunking capabilities to target larger file uploads. Our whole CLI is written in Golang. We're targeting like terabytes to hopefully petabytes worth of data onboarded. We've already integrated with S3, but we want to integrate with Singularity, which is the most prevalent deal preparation framework. And we want to get to a stage where we offer a parallel tool to storage providers, where they can offer the solution to their clients. The clients can generate encrypted car files, and the SPs can then ingest those encrypted car files offline or in a mechanism they see fit. But ultimately, I think in terms of future work, we really want to get to a stage where the metadata management is robust. So looking at tools like Fission's WNFS, they've been here and I've looked at their presentations, and their tooling is really impressive. So integrating with something like that to store metadata, following standards that are common within the Filecoin ecosystem for that metadata storage would be a key aim. Again, like focusing on the storage provider experience and making the onboarding of enterprise data seamless, I think there's tremendous opportunity there, and that's something we want to address as well. Now, switching gear from encryption to compute, which is actually my favorite part of all of this. There are several approaches towards achieving compute on encrypted data sets. None of them is a silver bullet. All of the solutions today have their own flaws and their own advantages. With fully homomorphic encryption, if just for everyone's awareness, it's a type of encryption that allows computations to be performed on the encrypted data itself without requiring it to be decrypted. It's pretty sci-fi kind of tech. I mean, it's really cool that you can not see the data and actually still derive value and analytics from it. Fully homomorphic encryption is the holy grail for the achievement of compute over encrypted data. However, unfortunately, fully homomorphic encryption is today not scalable. There are a number of open source libraries by likes of Microsoft and Google that do computations on encrypted data sets, but the sort of operations these libraries perform are quite limited and require very bespoke configuration to achieve. For example, Microsoft have a library called Seal that can do basic arithmetic computations on smaller data sets. There could be a scenario where you could actually create a version of Bacalhau using fully homomorphic encryption and actually run these simple kind of compute tasks. However, till the technology becomes a bit more mature and the encryption becomes more performant, I think its use cases and applicability are limited. Which brings us to trusted execution environments. Trusted execution environments are secure areas of a processor that can run verifiable compute. And by verifiable, you as the user can configure the exact algorithm that's going to be deployed inside this black box, and you can have strong guarantees around how the encrypted data will be handled, the output will be encrypted, and you can get real quotes, cryptographic quotes from the machine to guarantee that it has done what it is supposed to. TEEs are widely available today and quite mature. They've been around for about 5 to 10 years. And Big Cloud, as I mentioned earlier, has adopted them quite widely in the past year or two and offering them at scale to their users. These have their varied approaches towards achieving trusted execution environments. Intel have their SGX and TDX chips that actually work at the level of the processor, and it's an isolated region within the processor that is fully encrypted. Whereas AMD have a different approach where their technology is called SEV, and they are more focused on virtualization and running encrypted containers. The good thing about TEEs compared to fully homomorphic encryption is that they are able to scale. You can run complex computations using TEEs. You can do federated learning, machine learning over encrypted data. You can perform multi-party analytics and get encrypted data from multiple different sources, from distrusting parties, and actually perform like real, true multi-party computations, which is quite a new thing. Like it's not been possible before. However, these have known vulnerabilities. There have been instances where Intel SGX has been compromised. There are a number of these side channel attacks that have emerged. In fact, like 2 months ago, Intel revealed that they had a compromise in their SGX chip, which they have fixed. But with any privacy technology, it's a game of the attacker trying to outdo the defender, and you have that tension always. Sorry, I think I got a Slack message. Anyways, I'm gonna carry on. Yeah, so these are currently the most scalable way to achieve compute over encrypted data sets. They have the vulnerabilities that we know of. However, those vulnerabilities are being addressed by the chip manufacturers, and they constantly are rolling out patches to the hardware that prevent these vulnerabilities. There are other approaches beyond these two to achieve compute over sensitive data. Something called differential privacy, where you can, what you do is basically figure out the statistical values of the data sets and try to sort of recreate a new data set based on them. There's a number of startups trying to create synthetic data sets based on real data, and that is actually quite a interesting field of study on its own. There's a lot of applications for that in financial prevention of financial crime and fraud, where organizations can generate data sets that have the same statistical significance as the original one. However, in this, what you're really basing the synthetic data sets are on the statistical characteristics of a data set. So it's really not the underlying core data set. Which brings me to how we think we can implement privacy for the Filecoin network. We want to create a TE-enabled privacy compute Bacalhau. So we want to take Bacalhau and we want to extend it out, and we want to introduce T's as a means of execution of the Docker jobs. The Bacalhau client will have to run some infrastructure in this case. They'll need to run something called a key policy manager, which will be able to verify something called an attestation code, which is derived directly from the executor that's actually running the TE hardware. They can verify this by directly communicating with AMD, and they can guarantee that the hardware the code provided by the executor is genuine, it's running on a genuine AMD EPYC processor. They can configure their private keys on this key policy manager, and only when the correct executor requests the key policy manager with the right attestation code will the key be provided to the executor. This allows the Bacalhau clients to first onboard their encrypted data onto Filecoin, and then configure a Docker job, deploy it onto an executor, and then the executor can retrieve the private key, decrypt the sensitive data that's sent, and perform computations on it. This is something we're actually in the middle of building out. We actually got a grant from the Filecoin Foundation to deliver this, and this is something we want to hopefully deliver early next year. Great, so that brings me to about the end of this presentation. My ask and my call to action in this great Crowd-In presentation, there's actually two different ones. For storage providers, we want to work with you guys to really use our tooling to help you onboard encrypted data sets. Also, as I mentioned before, storage providers need this new stream of revenue. And I think privacy-enabled compute can be that mechanism that allows these storage providers to get more business, more revenue. So we would be keen to partner with SPs to help us test out this T-enabled Bacalhau and help us scale and find out flaws in our design if there are, and really build towards this state of encrypted compute. On the other hand, for the Filecoin builders and users, the storage and encryption tooling is going to be open source, which can allow you to easily onboard sensitive data sets to Filecoin. It's going to be available now, and we'd love to get feedback, build a community around this, and even develop this to become better. As I mentioned before, we want to offer a premium version of the same, where we have this decentralized key management and really upload of larger sensitive data sets. And finally, if app builders want to run compute over sensitive data, we would be keen to collaborate with them and test out this T-enabled Bacalhau. So that's all from my end. And yeah, thank you all for listening. Open to any questions now. Thank you. Yeah.
Thank you. So you're saying you store this in a decentralized way on IPFS. Do you have the location of all this encrypted data?
Yeah, so all of this is on Filecoin. So you would have the CIDs for each of those.
Do you have the location? So that's content addressable. Do you have location addressable?
Sorry, what do you mean by?
Do you know which nodes the sensitive data is sitting on?
So that's a very interesting question. So you mean the specific SP that the data would be stored on? So there's a bigger answer to this. So with the current implementation, we integrate with S2D. And S2D has a deal-making framework already baked into it. And the client does not have control over which SPs actually end up having a copy of your data. So in the current version of the tooling, you know where it ends up, but you don't have control over where it ends up.
So I'm just asking because the problem with this is if at some point, the 1%, the encryption that you use to encrypt this sensitive data is able to be broken. You need to be able to, with 100% certainty, be able to re-encrypt that data. Yeah,
but and this is an interesting area of research and discussion on its own. If you have that data on the Filecoin network, you really can't control the replication. Or you can make bespoke deals with the storage providers. So on that point, actually, we want to develop tooling for the SPs where they can actually control the ingestion of those encrypted car files. So today, the tooling is geared more towards the end clients, and that's why it integrates with S2D. But we want to build a tooling separately for storage providers where they can ingest these encrypted car files. In that case, how the deal making is done between the client and the SPs, the client can have guarantees around how many times the data is replicated. One of our partner SPs, Blocks, they have a mechanism to geo-ring-fence the data within certain geographies. So it really depends on the SP and the client's interaction, I think, in that case. Yeah.
Hi, great talk, thank you. My name's Phil Winder. I'm one of the developers on Bacalhau. Yeah. So I'd be interested in talking later. But one general sort of question: you were talking as if the things you've been talking about are an add-on. My question is, why couldn't this be the default for all Bacalhau jobs? Is there any reason why you wouldn't want to use encryption methods by default?
Yeah, that's a great question. I think I'll answer that. So TEs, even though they're very performant, still have limitations around the scale of processes that they can perform. I think the SEV chipsets can do terabytes worth of like processing, but not at the scale I think which Bacalhau eventually wants to target. So I think for larger computations that are on public data sets, there still will be a scope to have that default, like, a raw Bacalhau, which has no limitations on performance. But yeah, like for any enterprise encrypted data sets, I think terabytes worth of processing is enough usually. So in those use cases, I think it would be sufficient to have a T-enabled version be the default. I think from what I understand, you guys want to have a compute marketplace where there are many different executor implementations, and the client should get a choice to really deploy their workload on the right executor. So I think having that choice is always good.
Hi, this is Andreas from Legacy. We capture and preserve memoirs in the Solomon Filecoin. And depending on the user, the memoirs can be public or they can be private. Right? And so if they're private, they got to be encrypted. And so we just did a simple encryption. We run it on our own server, and then we just store the encrypted memoir on Filecoin. Now, where we want to go with that is that we encode the whole thing, or that we do the encryption inside a Filecoin virtual machine. Is that something what you going to plan to do in the future? Because it's really not our core competency. We're just doing it because we have to, right? But we would rather use a solution, from somebody who really knows what they're doing.
Yeah. So the answer to that is that doing encryption is not the challenging part. I think what we really differentiate ourselves on and what I think we care about is really the key management aspects and the performance in getting the data to Filecoin. And I think it's that part of it that we can help you out with maybe. Because the management of the encryption keys, recovery and really making sure that they're stored in the right way is what makes encryption really what it is. So if you lose access to those encryption keys, your clients lose access. They cannot recover the data. And I think that's really where we can add on to what you possibly have done. And I think our metadata management and how we map out the CIDs to the different data encryption keys and having that mapping built out in the right way, I think that's also like metadata and the encryption keys. It's all about that metadata management. If you lose that metadata, you lose sort of an ability to retrieve that data. So I think those aspects are where we can add on to what possibly you've done. Yeah.
That's great. A follow-up question or a related question is, also in our context, we're looking at access control. And I also do a lot of consulting for various enterprise customers. And there again, access control sort of is a big issue. We also looked at how this is done today in wallets, which is pretty much of a mess, right? Is that something you're looking into, like how you would adapt, LDAP, Microsoft Directory, things like this? I mean, is that going into?
That's a very interesting idea.
Hybrid solutions coming up there, or is that something which is going to be reinvented in Web3?
Yeah.
Just in general, would be interesting what your opinion is on that.
No,
topic.
that's a very interesting idea, and I think my co-founder and myself were talking about possibly integrating DIDs as a means of identity and tracking the public key pair, and that would be the true Web3 approach, is integrating DIDs as the identity. But I think, as Juan also mentioned in one of his talks earlier, that there needs to be a Web 2.5 approach where you can have what you said, the LDAP kind of enterprise technologies be the identity management. I think performing that integration and having that would be not that challenging. That's fairly mature technology, something we can look at. Yeah, would be keen to talk to you about that if you're interested. Yeah.
Hey, Alex from Ocean Protocol.
Yeah.
Going back to your Bacalhau T-enabled nodes. How do you plan to protect against a rogue Bacalhau node? Because I'm going to fork the Bacalhau node, I'm going to put it on the network, I'm going to support TE, and you are going to send me the private key, which was used to encrypt the data.
Yeah, I can answer that. So the actual Docker process you configured, the job, you deploy it inside of the executor. the executor cannot actually modify that exact process. Even the networking possible from that job is something you can configure and control, and the malicious Bacalhau node would have no way of retaining any job metadata or actually doing any kind of egress that's not pre-configured and known by the client. So, and you actually verify the entire job spec, not just the identity of the hardware. So you know that when you configure the key policy manager, it is the right node, the right hardware, but also the right job and with the right configurations that's actually trying to access your key. So you have strong guarantees around what's done with your data.
Okay, thank you.
Yeah.
Hi. At the start of your talk, you mentioned conservativeness from what I would call the old world.
Yeah.
So I was wondering if you were looking at the new world, like Vita DAO, a DAO that might just have the biggest data sets in the next 2 or 3 years if they get their strategy. So onboarding with new communities.
Yeah. So I guess to summarize, like what's the commercial approach going forward, right? Yeah, I think one of the good things about this ecosystem is that I think the sales funnel is almost like a community sales funnel, because you have these 4,000 storage providers whose job it is to actually source deals, because that's how they generate revenue. And I think our positioning and strategy is to really partner with them and help them have their funnel of possibilities broadened by offering this as a enhancer to the kinds of deals they can get. I think that's really going to be our strategy going forward in the near term, but I think we ourselves are looking at becoming SPs and actually procuring hardware. So yeah, I think there's enough. With eFill Plus, I think you should really, I mean, if you've not already, check out eFill Plus. I think Deep Kapoor at Protocol Labs is the one who's working on it. So he has a whole team working on a pipeline around ingestion. So.
I had another question from the enterprise context. So I've been talking to a number of companies who are looking into setting up data marketplaces.
Yeah.
Right, where essentially you have multiple companies, they all have proprietary data, they want to monetize the data, right? So they would only make the data available for a certain amount of computation. And and of course you want to avoid that anybody can download the data, right? Yeah. So is this approach you have here on the slide, is that going to cover that use case, right? So that you have, let's say, 5 companies, you have 5 different data sets. I want to run an algorithm over that. Yep. So that would be a way of doing that, right?
Yeah, so actually a bit more history around, like how we ended up here. We wanted to create a data union infrastructure for private networks. And we use certain technology that was a bit more, there were licensing issues around procuring it, so we couldn't scale that out. So that's why I think this sort of open, trustless architecture, where it's a common compute network that is yet secure and can be used by many different distrusting entities to perform these computations. That's why having such an open network that you can just trigger an interface with using a simple CLI. There's no licensing. There's no additional firmware you have to install. No additional infra that you have to operate. I think what you're saying, having this common privacy-enabled compute layer, is I think a game changer. And if it scales out well, you can have enterprises just coordinate, send their encrypted data to these executors, and really know what's going to happen with those encrypted data sets.
Yeah, well, that's cool. And I think that was also the answer to the question you asked earlier, right, about the monetization. Yeah. Because you have a data marketplace where people pay for stuff anyway, right? You can just take a portion of that by providing infrastructure. So that could be a sweet little deal for you.
Yeah, like that's something we should talk about. Yeah. Good.
Good. So 2 follow-up questions for you.
Yeah.
Thank you. One, so one of the other technologies that comes up in the ecosystem is the LIT protocol.
Oh, yeah.
Do you look at the LIT protocol and see it as something where you might integrate with them in the future, or maybe you would provide a similar service but that's more integrated into your own technology stack? Or are they trying to solve the same problem or different problems?
Yeah, just remind me. I've seen so many of these solutions that
They're doing key management basically. Like it's like some sort of threshold encryption over key management.
So that threshold encryption part is something we would love to partner with other companies that are actually building that tech. So one of the other ones that I've identified is called Web3 Auth, and they're open source. So I would lean towards open source integration around that rather than, but if what the lit protocol, if they're open source, then, we would love to like have this composability and almost offer the user a choice. You can like use this approach or the other one. So yeah, the answer is yes, always open to expanding capabilities. Yeah.
Very good. Yeah. And last question is, if folks want to get in touch and find out more about the work you guys are doing, should they go to your GitHub repo, website, email? What's the best way for folks to reach you?
Yeah, so all of them, and we're actually in the process of setting up like a new web presence, like a new website, and I'll share that on the Bacalhau Slack channel, and like it'll be broadly disseminated. So yeah.
Very good. All right. Thank you so much.